All right, good morning and welcome to Office Hours. The first question we have here is, would I recommend the mentorship program that myself and my co-founder Chase went through? So that program is specifically a program through the University of California at Berkeley. It's called SHE 256. And the basic idea there is that people who have blockchain experience become mentors for women who are interested in learning about blockchain. So you get paired and you have a mentor-mentee relationship. So I think it's a great program. It's a hit or miss. Just like a lot of things, a mentor and mentee have to have a synergy kind of, and it has to click. And if it doesn't click, maybe you go and say, I want a different mentor. But overall, I find that all the participants of that program, the organizers, etc., work really hard to create a great environment, and they're constantly innovating and trying to create programs that help. So I would definitely recommend. It's a great program, and I also like the fact that it's a fantastic play on SHA-256, which is, as you know, probably a hashing algorithm, and SHE-256 is a variant of that. All right, so our resident star Flappy Bird master has arrived. Welcome, Jacob.
Woo! Hey, everybody. I'm just trying to launch the project that we were working on yesterday for Office Hours. So just give me a quick sec here.
So there's a follow-up question meanwhile. So what is the mentor required to do? So that really depends on how you want the relationship to be. There are no hard and fast things, but in general, in any mentor program, you would expect that there would be a periodic meeting, maybe every couple months or something, and then maybe some emails are exchanged, etc. But really, it depends on how deep you want to go. Like if you are really, hit it off with your mentee, then you might have more frequent meetings, and you might be encouraged by their progress to help them more, because you see them making progress, etc. But it really depends, and there is no requirement per se. So hopefully that answers your question.
Okay, so I have the quest pulled up. I'm going to share my screen. All right. So yeah, so sorry I was a bit late, but here we go. So in yesterday's Office Hours, we went over how to do the stuff in Kibble.cdc. So the point here was, really to try and get you to learn how to modify your contracts in your DAppStarter project. So we went over how to modify the withdrawal function. We went over how to modify the deposit function. And lastly, we implemented the mint tokens function. So in today's quest, or in yesterday's quest, we had to modify the mighty dapplib and some of the transactions as well. So I'll actually pull up the quest here so we can all read it together. It's under week 2, day 3. And if I scroll all the way down here, we have, so I have one quest for you today, week 2, quest 5. You will only be modifying transactions, mint kitty item, transactions, transfer kitty item, and scripts, read collection IDs, and the dapplib. So please make sure to watch the videos, blah, blah, blah. So week 2, quest 5 has you trying to set up your transactions and scripts for 2 transactions, 1 script, and then to implement it in the dapplib so that, everything is set up. Now, for this quest, I already had it so the action cards were set up for your dapplib, and in today's content that we'll be releasing in a few hours, you'll begin to understand how the action cards actually call into the dapplib. But for the quest yesterday, you were just supposed to assume that was already set up, and that if you implemented your transaction and script and dapplib, that it would all tie together automatically. So let's go to our VS Code and go to the dapplib here. So if you search for to do, you'll see that there's 3 things to do. There's the first one is kitty items mint kitty item. So this says that it calls transactions /kitty item /mint kitty item the signer / proposer / authorizer is config.accounts@0. And I was telling you not to really worry about what this is too much until, day 4 content. But essentially, we're just going to stick this into the proposer field. So we know that's just going to get stuck in right here. Note mint kitty item takes in 2 parameters, the recipient and type ID. And note number 2 is that the proposer is always config.accounts@0 because that is the only account with the NFT minter resource. So we'll go over this in a second. But let's go to our README here and try and understand what the setup for a transaction function is. So we can see that under setting up a transaction function in Daplib, we have this kind of example, right? And it says that let's kind of walk through these steps here and see if we can follow these steps to reach our goal. So it says above is an example of how to set up a Daplib function to call a transaction. We start off by setting result to an async call to blockchain post because it's a transaction. So let's start by doing that, right? Let's start doing that here. So we can see that we have let config equals daplib.config, and that's because we're going to be using config.accounts@0. So let's start by doing that. Let config equal daplib.getConfig. All right. And then the next step was to set let result equal to an async call to blockchain.post. So let's start doing that. Blockchain.post. All right. Now if we open this up, the first parameter to blockchain.post is an object that takes in a config and a roles. So the config just always maps to daplib.getConfig, so we don't have to think about this one too much. And I've already set this config variable equal to daplib.getConfig, so we can just plug in config here. And then the next thing that it takes in is a roles key, and roles takes in one thing, which is a proposer. And this is the account or the address that's going to be signing this transaction. So if we go into any script, let's just go into kitty items, mint kitty item, which is right here. You'll see that the signer is this auth account right here. So whatever we put in the proposer, this will be that account. So let's go back to our Daplib, and it's telling us in our hints that it should be config.accounts@0. .accounts@0. And one of the things that I introduced you yesterday was what this actually means, what the syntax means in the context of DAppStarter. So config is your dap-config.json in your source folder. And when we're accessing .accounts@0, we're accessing this array and then the first element, or the 0th indexed element, which is 0x01c blah blah blah. So the reason that we actually want to get this as the signer and not have it passed down from the client, like if you'll see in other examples like data.signer, this is coming from the client in a data object. This is coming from config.accounts@0. So the reason we want to do this is because all of our contracts are deployed to this address, right? 0x01c whatever. Now, granted, we could have also just copied this and gone to our Daplib and just pasted this here, and this would have worked totally fine as well. But sometimes I like accessing it using the config and accounts array because it's just easier for me to understand. But the reason we're doing this is because if we go to our project, click on kitty items and scroll all the way down to the bottom in our init function, you'll see that the minter is stored to this account storage. So 0x01c blah blah blah, and no other account. So it doesn't make sense in our Daplib to have this be passed down to the client because it's always going to be config.accounts@0 anyway. So this just helps us set up our transaction function. Okay, cool. So now that we've done that, the next thing that blockchain.post takes in is the transaction that you want to be calling. So the syntax for this is you want to put the name of the folder that the transaction lies in. So we'll say kitty items, followed by an underscore, because the kitty items because it's in this folder, and then the name of the transaction. So mint kitty item. All right. So the next step after that is to put in, put another comma, and then we'll open up an object that takes in the parameters for this function. So, the hint is telling us that it takes in two parameters, a recipient and type ID, but let's try and figure this out for ourselves. So in mint kitty item, you'll see it's exactly as I said. There's a recipient, which is an address, and a type ID, which is a UN64. So let's begin to do that here. Recipient.
Hey, Jacob, before you go there, I just think on line 188 where you wrote the name of the function to call, it might be helpful to show people in the dApp transactions what that correlates with. Our transpiler auto generates that for you. So if you're wondering what the heck is that pointing to, you can go into dApp transactions and take a look, and it's auto generated for you by the transpiler.
Yeah, so thank you for that, Nick. So, we're putting kitty item as mint kitty item here, but if, it is important to know that this isn't calling the .cdc, file directly. It's actually going into our, dApp transactions. And if we search up kitty items, oh, it's right here, actually. that's helpful. If we go, into our dApp transactions, you'll see that it's calling this function right here, right? Kitty item is mint kitty item. And it actually, what it did is it transpiled, or is that the word? Or yeah, I think it is. It transpiled our, .cdc code right in here. And it put it in dApp transactions under this function. And it wraps it in like the FCL, stuff that we don't want to worry about. But it's doing all that for us. And so this is why it's actually, this function name. So, and I got a bunch of questions yesterday about, dApp transactions and dApp scripts, and people were trying to like modify it. But remember that this file is auto-generated. You're not going to make any modification to this file because it's just completely auto-generated. It takes what's in, these .cdc files over here, and it transpiles it over. So
yeah, perhaps you can demo that, like just go and make a change in that file and then just change the script, name for a second. And
yeah, so let's let me save this. I don't know.
Yeah, whatever.
Yes.
Yeah, save that.
We'll see what happens when I yarn start.
Yeah, if you had already had yarn start running, it would happen on the fly. It would basically take care of that for you.
Yeah. So with same thing with like the contracts where, if I had, I'll show you when I already yarn start as well, but it is the same thing.
Yeah, I feel like it's a good thing to demo some of these things in context while you're kind of working on them, so people can have a better idea. That's so. Apologize for interrupting your flow there.
No, it's a good interruption. All right, so let's go to our dApp trends, and you'll see if I look up mint kitty, and you'll see that a bunch of stuff I put there is now gone. So yeah, so it's all gone. All right, and similar, like let's say I went to Kibble or something, and I made a change to here. Well, obviously this won't deploy, but if I save it, you'll see that this will start generating again, and it'll do it on the fly, which is super cool. So obviously that's an error because you can't just put a random word there, but yeah. All right, so if you go back to our dapplib transaction function, you'll see that we were implementing these parameters. So this had a recipient, and this takes an object that has a value, which I was telling you to assume that this just comes from the client. So all that we know now is that it's in this data object. So data.recipient, and the type is a, you have to use kind of like the FCL format here. So it's T dot, and this is actually using the onFlow/types. I think it's an NPM module. So you have to put T dot and then, what the type is. So in this case, it's just an address. All right. And also thank you, BC, for mentioning the typo on line 188. I saw that. Go, Jake. I'm just catching up, so kicking back and taking. Thanks, Ned. Yeah. So we'll go to the next line here, and let's go back to our mint kitty item, which is this transaction, and you'll see there's a type ID with the UN64. All right. So let's put a type ID, and this takes an object with a value. And you know what I'm going to do? I'm going to leave this blank and a type with a blank. And I'll actually ask you, to everyone in this office hours, what do you think I should put in for these two fields? It's a, it's a uint64 in this case. So this is actually kind of a trick question. It looks like BZ nailed it on the dot. Yeah. So I was hoping that one of you would actually mess up and tell me to do data.type ID like that. But yeah, you do have to put the parse in here. And I'm glad you were paying attention to that little quirk because of the fact that we're passing in an integer. Yep. Oh, did I actually? That's really funny. Okay, yeah. Well, actually, I'm pretty sure I meant to do that because I wanted to give you guys like a little hint about like the little quirk. So I'm glad maybe that saved someone a bunch of time. You never know. Stuff like that could cause people like 4 hours of pain, and it's just one it's just one thing. Yeah, it'd be terrible if you didn't. Yeah. I definitely wanted to show that. Okay. So we've done this, right? Now what's the next step? We can see up here that, if we put, let's just go down here. And this is where we're going to return stuff to the client. So we're going to add a return function here. And this takes in three things: a type, a label, and a result. So the result for a transaction is just always going to be result.callData .transaction ID. And I'll actually show you what these will do, like on the client side. We'll try and modify some of these to see what happens, but let's just kind of assume for now that this is what you would always put for a transaction. For a label, let's just put like, I don't know, what do we want to call this? Like a transaction ID or a transaction hash maybe. And then for our type, we're going to put, what is this? It's a dap lib transaction hash. So this one right here. So we'll put, right? Yeah. Okay, cool. So let's put our commas here. So this is what we're going to return to the client with the transaction. So now let's actually save this and, go to our client here. And let's see. We can't run this, right? Because we haven't implemented the transaction yet. So let's actually write our transaction. So kitty items mint kitty item, which is this one right here. And you'll see that, as always, I've left, some comments here for you because I didn't want this to take too much time. And I know that you've already had a bunch of practice with transactions, but, hopefully this was still helpful. So, our to do is this little Zoom window is blocking me. Hold on. So it says to do add imports here, then do steps 1, 2, and 3. This transaction uses the NFT minter resource to mint a new NFT. It must be signed by the account that has the minter resource, stored at path, kitty items.minter storage path. So yeah, so this is why we always had to sign with config.account@0. All right. So our first thing is to borrow a reference to the NFT resource in the center of storage. And, we're just assuming we're mapping that to this. So self.minter equals account.borrow. And this is going to be, it's account.borrow, and we're borrowing in a, kitty items.nft minter from, and, instead of doing like our normal storage path like this, which you definitely can do, but, one of the things that we set up was, in our kitty items contract, we actually, like I showed you that you can set these path names like this. So for example, minter storage path is just storage/kitty items minter. So, you can do it just like this as well. And this is signer.borrow, right? All right. So from, and I see that BZ says typo line. Oh yeah, I love that. You always catch me. I promise I did see it on my own. Okay, so kitty items dot minter storage path. All right. Now let's also, before we forget, let's make sure to import kitty items. So import kitty items from project dot kitty items. Now the reason we're doing project is because the kitty items contract lies in the project folder under our contracts, and then we just put the name of the contract. Now we also could have, if we could have gone to our dap config and seen that it's called project.kitty items, And all this is doing, in our daplib, or sorry, in our transaction, is when this gets transpiled, right? Like when dap transactions takes this code and it's placed in there, all it's doing is just replacing this with an address. So that should be simple enough. All right, cool. So let's add a panic here. We have a problem. We can't borrow the kitty items NFT minter. All right, so this panic will, just abort the transaction if we can't borrow. Now, I haven't really talked a lot about panic, and I don't know if Morgan talked a lot about panic, but essentially what happens is, as far as like if something goes wrong, right, it's just gonna panic and be like, we can't do this, and it'll stop the transaction. But it's important to note that at any point in the transaction, if we have a panic, it completely reverts the entire transaction. So I'll give you an example. Let's say we borrow an NFT minter, then we borrow a collection or something, and then we mint into that collection. And then, that collection now has like a new NFT, right? But then afterwards, we try to, I don't know, transfer it all in the same transaction, and that panics. It will completely revert everything, so that collection no longer even has that minted NFT. So what happens to the gas fees when it reverts due to a panic? Nick, are you able to answer that?
Yeah, so in most blockchains, you have this pattern, which I'm going to be talking about in one of the upcoming videos. It's called fail fast. And the idea is that you fail as quickly as possible, because the way blockchains work is that as lines of code are executing, that is essentially creating cost. So even though your transaction might be reverted due to the panic, there was some work done by the computer that processed the virtual machine that processed that code. And so it is going to cost you till that point. Now, having said that, keep in mind that all the Flow stuff is still in beta, if you will. Things are changing, and there's not a lot of things related to pricing, etc., that are fully baked yet. So, but 100% in Solidity, Solana, etc., and every other blockchain that I can think of, you pay until the point you abort the transaction. So I don't know why Flow would be any different, because the computer, the node that's doing this, has to be paid. So that would be the pattern.
Yep. Thank you, Nick. All right, so let's go to our number 2 here, which says to borrow a public reference to the recipient's kitty items collection. All right, so self.receiver equals get account, recipient dot get capability. And inside this get capability, we would usually put some sort of thing like /public/something, but handy to us. If you go to our kitty items contract, you can see that there's already a public path set up, which is called collection public path. So we can just do kitty items dot, wow, I have short-term memory loss. Collection public path. Okay, collection public path. All right, now let's borrow this. And this is where we specify the type, which is non-fungible token dot collection public. And then lastly, we put these little parentheses here and we panic. So if we can't borrow this for any reason, let's just say we can't borrow the public kitty items collection. All right. Now, this is like a super small thing about capabilities. But I do want to mention that, a lot of times you'll see, for some reason, the Flow team loves to do something like this, where they'll say let receiver account equals get account recipient, and then they'll just replace this with receiver account. I don't know why they do that. I think it's it's an extra step for no real reason, but I just wanted to mention that because that's a pattern you'll see sometimes. But I just like to put the get account right in there. What is your favorite blockchain and which would you recommend for gaming? Oh yeah, so Nick will give a good answer for that. So for number 3, mint the NFT and deposit it into a recipient's collection. So we've already done our borrowing. And also I just wanted to mention that if you read on the Decentology website, we released an article that I wrote about best practices in cadence or some errors that I saw in with cadence for the first week of Fast Forward. And actually, one of the points I talked about was the separation of concerns between setup in our prepare and execute in our execute. So I always think it's best practice to put your borrowing and your capabilities inside the prepare phase and then put everything else in the execute phase. So that's why we kind of flipped it here. So the execute is 3, mint the NFT and deposit it into the recipient's collection. So self.minter, right? And how are we going to use the Kitty Items minter to mint an NFT? Well, let's go to our Kitty Items contract. And NFT minter has a function called mint NFT that takes in a recipient and a type ID. So mint NFT that takes in a recipient, which is just our self.recipient, and our type ID, which is just our type ID that we pass in as a parameter right here. All righty, so this should be done, right? Oh, no, it's not actually, because we forgot to import our non-fungible token from flow.non-fungible token, which just comes from this flow folder right here. Okay. So it's transpiled, you can see that it automatically transpiled our transaction. And if we go back to our, harness, we should be able to, mint a Kitty item. So let's do all of our setup. Submit this as well. Let's get our balance, just to make sure everything is set up correctly. Get supply. Let's mint tokens in the admin account. Let's transfer some from the admin to Alice. Also, I got a bunch of questions yesterday in the Burning Questions channel about, JSON decoding structure being off. That's just because a bunch of people were forgetting to put the decimal here. So they were putting in something like 10 and not 10.0. The reason for this is because in Flow, a UFix has to have a decimal. And, for some reason also, I don't know if you'll encounter this, but in your DAPlib, I spent so long on this error one time. If you have a UFix 64, like let's say we had another thing right here called, I don't know, this is UFix 64. And, we put in a value that was like data dot, this is UFix 64. A lot of people, or at least me, when I was first starting, tried to put like a parse int around this, but for some reason, the transaction likes when you pass in the UFix 64 as a string. So just make sure you're doing that as well. So make sure it's a decimal and that you're not parse inting it. Okay. So let's try to make sure that our transfer worked, which it did. Get supply. All right. And now we're going to set up our account for Kitty items. So some fun stuff for day 3. Let's set up both of our accounts. And so we just wrote the mint Kitty item, transaction. So let's try and do that here. So let's try and mint into the admin, account, which is, and we're just putting in like a random type ID. So like 5 or something. And let's submit this. Let's see if we get an error. Oh, look, we got an error. So value of type transaction is no member recipient. Okay, so let's go and see what I did wrong. So the recipient is it's self.receiver. That's why. I guess I probably should have named this recipient to make it more clear, but yeah, it's self.receiver. All right. So let's transpile that. Go back down to mint Kitty item with 5, and let's mint into the admin account. And we get our gold star. Woohoo. So in order to check this, let's scroll down a bit. And, we actually need to implement this read collection IDs, so we can't really use this. But let's use this one. This is already implemented. And if we check it, it says that the admin has, 1 Kitty item. So cool, it worked. Sweet. And actually, this one is also working as well. So we can kind of use this as just a check. It says read Kitty item type ID. So in the admin account, we know that we minted something with an item ID of 0, and it gives us back the 5 that we typed in. And, lastly, we can use like this, this script to see that, oh yeah, there's 1 Kitty items in the total supply. Cool. So the next thing we have to implement is transfer Kitty items. So let's go and tackle that. Now, I'm not going to walk through this step by step because we actually just did that for this transaction function. So I'm going to copy and paste this format over, and let's just make the modifications we need for a transfer Kitty item. So, we can actually get rid of this and just put daplib.get config directly in here. And for our proposer, it wanted us to put right here, data.signer. So data.signer. This little string here is no longer, kitty items mint kitty item. It's transfer kitty item. And this takes in two things, a recipient, which we've already put here, so I'll leave it, and a withdraw ID. And so this is going to be, data.withdraw ID and a type of t.uint64. So let's actually check that I'm right. And it's a uint64. All right. So we've already set up our, transaction function. And I wanted to do this also because I wanted to make it clear that it's not every, function you set up. It's going to take, long like we did over here. I was just, trying to walk through every step. But when you're actually developing on DAppStarter, you can see that I just copy and pasted the format and change 3 things and it's going to completely work. So that's why I really enjoy, using this kind of setup because it's so quick and so easy. So let's go back and implement our transfer kitty editor now. And this is going to be very similar to what we saw before. So self.signer collection ref equals signer.borrow a kitty items.collection. And this is from, kitty items dot collection storage path. This is the same thing from the previous transaction. We're going to panic. Couldn't borrow the kitty items collection. Oh, actually, wait, no, this is not the same thing because the last time it was the minter. So in this one, we're just using, let's go to our kitty items, contract. We can see that the collection storage path is right here, right? So we could have also just put /storage/kitty items collection, but we're just going to use this helpful naming. So collection storage path. All right. Now we're going to borrow a public reference to the recipient's kitty items collection. And this is the exact same thing. So I'll just walk through this again. Self.receiver collection ref equals get account recipient dot get capability. And this is the same thing as before. So kitty items dot collection public path dot borrow at non-fungible token dot collection public. And this is just because this is what I defined right here. Put our parentheses and then panic. Borrow the public kitty items collection. Okay, cool. So we've done our prepare phase. Now, let's make sure that we add our imports. Import kitty items from project.kitty items. Import non-fungible token from flow.non-fungible token. Cool. Now we can do our execute. So the step 3 is to withdraw the kitty item from the signer's collection. So this is the signer's collection. Let's do let kitty item be a, so self.signer collection ref dot withdraw. And let's see what this takes in. So in our collection, we have a dot withdraw, and this takes in a withdraw ID. Cool. So pretty simple. Withdraw ID, because we're just passing that in as a parameter. And this will, this function returns a non-fungible token to NFT. So we're just going to store that using the move operator inside our kitty item. Now deposit the kitty item into the recipient's collection. Okay, so what does deposit take in? Deposit takes in a token that's a non-fungible token.nft, which is exactly what we returned here, which is exactly what we stored here. So self.receiver collection ref dot deposit token our kitty item. All right. So if all went well, this should work, and let's test it. So let's transfer a kitty item from the admin to Alice, and the withdraw ID is going to be 0 because it's the only kitty item that the admin has. We get our awesome gold star, and let's read our collection length for the admin. It's 0, but Alice should be 1. All right. So we only have one thing left, which is read collection IDs. And this is a little bit different because this is now a script. So, we have a to-do, read kitty items, read collection IDs, propose or none, blah, blah, blah. So let's copy and paste this format again and just make our modifications. So right off the bat, there's one modification because this is a script. This should be blockchain.get, right? We have our config, which is the same thing. But because it's a script, we actually don't even have a proposer because, with scripts, no one's signing that execution. Then for our script, we want to run kitty items read collection IDs. So let's just change this to read collection IDs. And let's see if it takes in any parameters. So inside our script, inside kitty items read collection IDs, this takes in one thing, which is an address. So let's make sure we pass that in. So an address. We're going to assume we get this from the client. So data.address, type t.address. Okay. And the return value for scripts, for script functions in the daplib is a little different. So we want our type. Let's go to our read collection IDs. We see that we're returning an array. So it's actually really helpful that because we can put daplib.dap result array. And this will, take our array and format it for us on the client side correctly. And I'll show you how that happens. So let's leave the transaction S here for now so we can see what happens. And for scripts, we always return, result.call data. So let's save this. And I'm going to leave this here for now so I can show you how, what this does. But let's go to our script and implement our script now. So the Zoom window is blocking me again. Okay, so let's go to our first step. This is to get a public reference to the address's public kitty items collection. So we've done this probably a billion times at this point, but let public kitty items collection equals get account address dot get capability to kitty items dot collection public path, dot borrow. And okay, so this is a cool thing to go over. So let's import, our kitty items from project.kitty item. So this should be right. So this should be non-fungible token dot collection public, and then we'll panic. We say we can't borrow the kitty items collection. All right, let's also import non-fungible token dot flow dot non-fungible token. Now, I want to come back to this in a second, but let's do our step 2 here, and then we can come back to whatever this is. So return the collection IDs. Hint, there's already a function to do that. So we can return the public kitty items collection dot, and we want to return the collection IDs. So let's go to our kitty items contract. Let me get rid of some windows here. Let's go to the kitty items contract. We want to return the IDs, which is get IDs to this function. Now let's see actually, is this function, let's see where, which interface exposes this get IDs. So if we scroll up, we can see that, collection implements 4 things. So kitty items collection public, which is, defined by us here, a non-fungible token provider, receiver, and collection public. This all comes from, the non-fungible token contract interface. So I won't pull up the non-fungible token contract interface, but assume that the get IDs function, or just trust me that the non-fungible token, that collection public, exposes the get IDs, function. So this is why we're doing, a non-fungible token collection public. However, if we look at here, our kitty items collection public, this also exposes our get IDs function. So we also 100% could have just put kitty items collection public, and then look at this. Now we don't even have to import non-fungible token. So that's just a little thing that you can look out for to maybe get rid of an import statement here and there, that this also works completely fine. Now, let's go to our setup, right, where we set up kitty items. We're only allowed to do this if it was linked in such a manner. So we go to set up account, you can see that when we linked our kitty items collection to the public, we, passed in, or we exposed non-fungible token collection public And we also expose kitty items, kitty items collection public, which is why we can use either one of them. All right. So then return public kitty items collection dot get IDs. All right. Let's hope that this transpiles. Oh, we have maybe an error. So missing contract address for, did I make a typo here? Oh, yes, I did. Provided that kitty items. All right, cool. It transpiled successfully. Now let's scroll down. Oh, let's scroll down. It's probably just transpiled again. And now let's try and read collection IDs and see if this works. Oh, I got a problem. So expected token, as you failed expected token. Let's see, what did I do? Oh yeah, I forgot to put the parentheses here. I'm glad we encountered these types of errors together. Transpile again. Okay, let's go back. So then let's read collection IDs for the admin. And you'll see that there's nothing in here because the address doesn't have anything since we transferred it to Alice. Now if we go to Alice, you'll see that, boom, it's right there. Now let's see, you can see here that it's returning like result, right? But if we go to our, daplib.js and we go to this label, let's try and change this to this read collection IDs, right? Let's try and change this to collection IDs and see what happens. Scroll down to read collection IDs. I must be doing something wrong. Usually this would change to, I might be doing something wrong, right? Because if we go down to this example, you'll see that honestly, it might just be because it's an array, but I'm not entirely sure. I think I might have messed something up along the way.
Is that returning an array? You marked the type as an array, but
yeah, the KM's collection IDs is returning an array of UN64.
Okay.
It might just be because it is being buggy with the DAP result array here instead of like a big number, but the label should work regardless.
Yeah. One thing I like to do in these situations is just console log result right before the return statement.
Yeah.
You can see actually what's going on.
Yeah. And BZ says, shouldn't it be type daplib.dap result big number? No, because like that would be the case if, for example, we were returning like a UN64 here, because that just returns a number. But if it's an array, then we actually want to return a DAP result array here. Yeah. And similarly, like if this was like a dictionary, we would want return a DAP result object. But yeah, let's actually console.log the result and see what happens. So let's go to our read collection IDs and go to our console. Oh, so this way,
browser console.
Oh, yeah. So it logged an object. That's just an empty array. But if we do like Alice, for example, we should see that the that call data is a array with 0 in it.
So then your result is displayed correctly.
Yeah, but it's this that I'm talking about. Like this result, this label should be, because like if you go down here with the length, it shows the correct label that I defined in like right here. And I'm curious why this is returning like result.
Yeah, it's not putting the label there.
Yeah. Well, we can try and debug this at a different time, but it's not too important since it's just a label. But I'm curious though, like, yeah, no, it should be working.
Well, can you go to the action card?
Yeah. A little sneak peek for day 4 content.
Actually, this wouldn't tell you here. You would have to put a breakpoint in the browser debugger to be able to see it.
Well.
Yeah, that might be overkill for what we're trying to do here.
Yeah. So we'll leave that out for now. But we'll look into this, and just as a general thing, like if you whatever label you put here the point I was trying to get across was that, is reflected. Like, for example, let's submit this, for example, and this says transaction hash. That's because we put transaction hash in this label. So I guess it just, for some reason.
Can we try one more thing on that line preceding? Copy that constant, the DAP result array part of it, just that part, and then just search for that, but not daplib, just result array part, and just search within this file. You should have 2 to 3 instances of it. So go to the end of the file where it's actually being there's a so it returns an array, and then let's see, keep going. There we go. All right, so yeah, it's and then can you look for the sorry to go down this rabbit hole, but can you look at the format array function, because that's where it will either, you might have just found a bug where I forgot to put the label, and sure enough, I did not put the label. The label is ignored here. Okay, we'll fix that.
All right, so there we go. Discovering bugs on the fly.
Yeah, I wrote that code like almost a year and a half ago now, so I barely remember it. Okay, so I'll go.
I'm surprised I haven't seen it up to this point, but yeah. So there we go. Okay, nice. We tackled that. We tackled that problem. But anyway, yeah. So that is day 3 for you. Let's go through all our action cards here. Let's mint another one into, I don't know, Alice's account or something. So now Alice should have, a 0 and a 1. Alice should have, a 2 in here because that's the collection length. Let's see, the total supply is 2. Read kitty item type ID. What did we type in for 1? We typed in 5 again. So yeah, that's day 3 stuff. I still have to release day 4 content today. That's going to go out around 1 p.m. EST. And that's going to cover the client and it's going to answer all your questions about, what actually does data.price even mean? What like, how is that coming from the client? How is it getting passed in? How is this even being called? That will all be answered today.
All right. So there's we'll wait to wrap up any questions related to the code, and then I'll go back and answer some of the general blockchain type questions that Busy had.
Sweet.
Biz had.
Biz.
So he says, wait, the dApp starter recompiles transaction and script changes immediately. I didn't know it compiled automatically. I thought I had to close dApp starter and redo yarn test, yarn start, then do setup from day 1 to day 3 in order to every time. Oh, so the whole point of dApp starter, we built it to save you time. So what you would do is put yarn start in your console and then forget about it. You should continue editing your code, editing your contracts, editing all of that, and it just hot loads. It might take 2 to 5 seconds, but it just hot loads. And that's why you'll see your, like as Jacob is working, even in like some of these scripts, etc. If you kept the browser window open on the same screen, you would see that it just reloads right away. You do not need to restart anything. You do not even need to restart when you redo or change the contract, because it automatically redeploys it. So it's ultimately, we want you to focus on the code and not worry about all this rinse, repeat, do the same sort of, I call it monkey steps, again and again. We don't want you to do that. So yeah, all automated.
Yeah, Biz, we'd be failing you if you had to do that every time. That would stink.
Yeah. If you want to do it, you can, but you don't need to. Good question is about how do we debug? All right, so that is a loaded question because it really depends on what it is that you're trying to debug. So if you're trying to debug your contract code, then really the best way to do that is with unit tests. And Jacob's going to cover that, or has already done that. No, you are going to.
No, that's today.
Yep. So that is how you debug, because you don't really have, at least right now, the ability to step through it, etc. So unit tests are the best way to debug the contract code. Then it comes to things like daplib, etc. So on that, you can just debug normally. Visual Studio Code recently introduced a feature where even your browser side code you can step through directly in Visual Studio with breakpoints and all that. I'll dig up the link of that announcement and post it into the Fast Forward channel, so you have that. But barring that, you always have the ability to go into your browser console and set up a breakpoint. What I like to do is often, and actually, if you don't mind, Jacob, demonstrating that, like let's take the function you've got here, static async kitty items, market sell, market item, blah, blah, blah. So on line 433, just put the word debugger and save it. And then let's go explore.
Oh, do you want me to actually like run, because this probably isn't a good example.
Yeah, this is, oh, it's not a good example.
No, because they still have to set up the kitty items market. Let's put it like I don't know, over here or something. Read collection.
One of the ones you were using just now. Yeah.
Yeah.
Just save. So this is one way to go about it. And then just run it. You don't need to do inspect also. So that I wanted to demonstrate that. Yeah, you do nothing. So just hit that. And
the right one? Yeah, it should be.
Well, on Firefox, it opens it directly. So maybe on Chrome, it didn't. Can you go back to inspect then? So I was wrong. I wanted to demonstrate a feature, but that didn't work very well.
Maybe I'm just doing something wrong.
No, you should at this point. Are you sure you're doing that the correct function though?
Yeah, it's read kitty item type ID, and this is kitty item type ID.
Oh, you know what? I'm gonna bet you when you hotload things, the debug type things are not there. So for that, let's see. Can you go to sources?
Oh, there we go.
There
I just had to refresh the page.
Yeah. All right. So you see that it automatically now hit that breakpoint, and you can now step through the code and look at everything, etc. So you don't need to do it that way. If you go to sources, you can also click in, like click to the left of like 294, line 294 in your sources there. Just click to the left of that line. Yeah. And now you can go back and get rid of debugger, save it, and hit reload on this page, and you'll see that it still works. Yeah, there you go. And go back to that, execute that code. Bam, there we go.
Boom.
Breakpoint. Now there is a little known feature of browsers called log points. Most developers have never heard of it, but we spend a lot of time doing console log, etc. But log points are an amazing feature. What they let you do is, without adding console log in your code, they allow you to log stuff by using the browser's console to determine where you want it to be logged. So if you just Google log point, or even in Chrome, right? So if you just do Chrome log point, it'll give you step-by-step how to do that. But it's a really powerful and cool feature. The benefit of that is, as a developer, you don't have numerous console logs all over the place. Yeah, you should go to that one. The first one is good. Yeah, log points right there. Yeah, so that came out in 2019, but still hardly any developers use it because it's an underused feature. If you go scroll down there, it'll show you screenshots. There you go. So you basically go to any point and say add log point, and then you can even set rules and say that log if, for example, the value of X is blah, 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 whatever, just write a console log, otherwise do nothing, kind of. So this is essentially console log on steroids without you editing your code. So log points are really useful for that.
Sweet.
I just read BZ's comment about feel like knowing that before yesterday would have been nice. Sorry about that.
Yeah, sorry, BC.
You know, with DAppStarter, we've become so familiar to like not thinking about these things that we forget sometimes that all the work we've put into all this automation is the value proposition of DAppStarter. We need to be more overt about them. There's so many hidden things that way. Like for example, all the automation scripting that's there around generation of test accounts. Even right now, had you been doing it from scratch, you would be spending 90% of your time just figuring out how to sign a transaction. Honestly, I've done enough blockchain apps to know that, and with Flow, with the fact that there are roles, there's a payer, a proposer, and authorizers, or whatever they're called. So you would be spending a lot of time on that instead of actually just having the joy of seeing your code work. So what we like to do is we like to defer the pain, so or eliminate it, in a lot of cases. So yeah. Okay, so I think I can go back and answer that question about my favorite blockchain, etc. So yeah, I wasn't being facetious or anything like that. I think for NFTs, it's just straight up, Flow with Cadence has built this architecture around resources, etc., and it makes so much sense. It maps it. Honestly, I haven't done enough work in Cadence yet to say how well that would translate over to a general purpose, what I call a utility, a smart contract. So for example, let's say that I was creating, I have a good example. So I taught the Udacity blockchain nano degree for Solidity, basically. And in that, I had to come up with a reference app for the students. And so I came up with this thing called Flight Surety. It's essentially insurance for flight delays. So the way that would work is, as a passenger, you would buy flight surety before the flight took off. And because there would be an oracle that records when the flight landed, it would tell the smart contract the flight landed on time or the flight landed late. If the flight landed late, the contract automatically pays you money. And that's basically flight surety. So I can't imagine that kind of thing being built on Flow today, maybe later, because of all the vectors around Oracle, moving money, etc. Because how would people efficiently buy that? How would the money get distributed? How would the Oracle work? I think all of that is possible. It's just that it's not as fluid right now as it is on Ethereum or any EVM for that matter. So that's what I would use another blockchain from. I also mentioned Solana. So setting up DAppStarter to work with Solana was probably the hardest thing I've done computing wise in my life, but got it working. And now that it works, it's beautiful. I'm not a Rust developer, but if you know Rust is a great language for when you want a high degree of specificity and really accuracy. That's why they write low-level systems, etc., like car systems and all that in languages like Rust. So Solana is wicked fast, and so I would use that for a DeFi type application. So there are other chains, like for example, there are chains like IoTex and IOTA, etc., that are making leaps into the world of IoT, where you have like billions of transactions, and what do you do with them? How do you deal with them? And those are special purpose blockchains. So I see lots of special purpose blockchains emerging. If you look at Substrate, for example, Polkadot Substrate, it allows you to essentially create an L2 or level 2 blockchain or sidechain or parachain, as they call it, of your own, and easily custom build it, configure it, and get it running in an afternoon. So I think that's kind of cool. I think we're going to see more special purpose blockchains emerge, and some of them will be more successful than others. But general purpose blockchains like Solidity, like Ethereum and Flow, I think will continue to dominate. Flow makes it doesn't pretend to be anything other than the blockchain for creators. It's designed for brands. It's designed for that. So I think you're going to see, you mentioned games. I think games are going to be a big thing on Flow. They already sort of are in a little way with NBA Top Shot leaderboards and things like that. But I predict that games will be very big on Flow as it evolves. So anyway, those are some of my thoughts. I'm in a very interesting situation because um, I've had I don't know if it's the good fortune or the misfortune, it's still an evolving thing, of integrating every blockchain so far that we have onto DAppStarter. So I have had to dive very deep into the SDKs of every one of them and what works and all that. And I see some common threads. I can see, like I can literally go to a blockchain documentation page now and tell you what is the developer pain level going to be. I've gotten fairly good at that. And the blockchains that actually take time to focus on their SDK do well. And the reality is that most of the blockchain engineering teams consist of protocol engineers, and thinking about the developer that will build upon it is sort of a secondary thought. And I think that's changing now, but that has been the case at least for the early years. And so it's been really frustrating to work. And that's what actually was the genesis of DAppStarter, is like frustrating. And even now you go the documentation, I guarantee you, of every blockchain, pick anyone, it is 100% inaccurate with what the product actually is shipping, because there's a lag time. So that's the challenge with developers. Like they download the latest software, but like, oh, it doesn't work. They go to the docs and says it's supposed to do this, but the docs are behind. And so you get stuck. So very challenging. Anyway, I was just rambling on. I apologize. But if there's any other questions, I'm happy to answer them. Yeah, I would recommend Flow for gaming. I think it is definitely a good place. Now, keep in mind that Flow is early right now. So if you're going to submit an app and want to hit mainnet, you have to go through an audit process. And currently that audit process is slow. It might take like as much as 4 weeks or something. So if you're in a hurry to launch, then keep that in mind. It's not a bad thing. It's just that right now, because it's still in beta, they're trying to make sure that they don't have some scammy smart contract that is going to steal everyone's money, get on there. So that is a constraint, but that's going to go away. And as I mentioned in yesterday's office hours, we are building a platform where these blockchain primitives, especially starting with Flow, are going to be on there. They're going to be audited. They're going to be insured. So if you use those blockchain primitives, then you wouldn't have to wait as long because they're already audited. So what about our curriculum is most relevant for Flow advantages? Well, everything that Jacob's been talking about, NFTs, etc., is 100% in the domain of Flow. We expect fully that, if you're thinking about an app for Flow right now, there's probably some NFT element to it. So I think that's the low-hanging fruit there. Yeah, so the question is, if people were to copy directly, take an exact smart contract copy, and would Flow accept it for deployment to mainnet? I don't know. You'd have to ask them, but I think it would depend on the hash. So, you would need to probably convince them that, hey, look, the hash is equivalent. So I'm going to presume that they would. But honestly, if I was Flow, I would push back and say that, well, let's talk about composability. Why do you want to deploy your own copy of it? And blockchains are about efficient use of resources, and so that's the model that we are trying to go towards, is composability, where if there's already the exact same code on the chain, why would you want to duplicate it? It's like saying that, oh, I've built this API, let me rerun this API at another web URL. It doesn't make sense to do that. Instead, you should just be able to point that contract to a different storage location on chain. So each contract has its own data, but the app logic is shared. It's immutable. There's no risk to it. If you're just copying it, might as well use composability as an architecture design pattern instead. All right. Let's see. Are there any more questions? Yeah, we're going to talk a lot about composability next week, because we see that as an important thing for developers to know and understand and really collaborate, because there are a finite number and a very small number of blockchain developers right now. And if we can all create primitives of what excites us or we are knowledgeable about, then other developers can benefit from that. And just like Web 2 took off when people started building APIs, like payments were a struggle. Stripe came along, add 2 lines of code and payments is solved. It's just like that. We want developers to solve core problems that can become primitives, and then other people can compose and use those and get their apps running super, super fast. All right, I think that's a wrap then. Thank you very much, everyone, for attending, and we will post this video in the channel for others who could not attend. And as always, we'll be available to answer any questions you have, debug, help you in any way possible. Thanks so much. Thank you, Jacob.
Yep, thank you, Nick. And day 4 content will be out in about an hour, so look forward to that.
Thanks. Bye.
Bye.